A very happy and a pleasant morning to you all children. I'm extremely happy in making you to meet at this early morning. Today's lesson will be the continuation of the last week's lesson, that is force and laws of motion. Children, we have discussed about inertia, types of inertia. Then we have applied the knowledge of inertia in understanding Newton's first law of motion. And today we will extend the lesson in learning Newton's second law of motion. Newton's second law of motion is a very important relation which gives F equal to ma as an equation, where F is the force, m is the mass, and a is the acceleration. So while we have learnt about balanced force and unbalanced force, we have studied that unbalanced force produces acceleration. So this is the main concept of Newton's second law of motion. When the forces are not balanced, then there will be an acceleration in the body. So we will see to it, and also we will see about momentum. Then we will apply momentum, force and acceleration, and we will derive an equation F is equal to ma. And also we will discuss some of the day-to-day events where it is an application of Newton's second law of equation. Right? Let us go to the lessons. Children, let us start today's session with a new physical quantity called momentum. The word momentum you would have learned earlier. Now let us see the definition and meaning for the word momentum. Momentum is the quantity of motion contained in a body. That means if a body has a mass m, then if it moves with a velocity v, then the product of its mass and velocity together we call it as momentum. So momentum can be defined as mass in motion. All objects have mass. So if an object is moving, then it has momentum. That means it has its mass in motion. The amount of momentum that an object has is dependent on two variables. How much is the mass of the body and how much is the body moving with. Momentum depends upon the variables mass and velocity. In terms of an equation, the momentum of an object is equal to the mass of the object times the velocity of the object. So as I told, momentum has a formula, mass into velocity, and we usually keep the letter P for momentum, M for mass, and V for velocity. Therefore, the famous equation for momentum is P is equal to mv. This slide also gives a brief meaning about momentum. The momentum of a body is the product of its mass and velocity. Momentum is equal to mass into velocity. P is equal to mv, where P is the momentum of a body, m is the mass of the body, v is the velocity of the body. If the body is at rest, its velocity is zero, and so its momentum is also 0. The SI unit of momentum is kilogram meter per second or kgm by s or kgms power minus 1. Example, a truck moving at a very low speed can kill a person standing in the path because of the heavy mass of the truck. A bullet of small mass when fired from a gun can kill a person because of the large velocity of the bullet. So, the impact of a body depends upon its mass and velocity. Children, here we go with the examples which we have discussed in the last slide. A bus can have large momentum even if it is moving very slowly because it has a large mass. On the right side, a bullet can have a large momentum even if it has a small mass because it is moving at a high velocity. In the first case, the mass of the body, that is the bus, is more. So we can decide that the momentum possessed by the bus is more even if it has less number of passengers. Now, when we compare a bullet with that of a bus, the mass of the bullet is negligible. But even this bullet, when fired from a gun, has a large momentum because here the bullet travels with a very high velocity. So, irrespective of the mass and velocity, both of them are having momentum at a greater extent. So, momentum is decided by the mass of the body or the velocity of the body. If the mass is more, momentum will be more. If the velocity is more, momentum will be more. If mass and velocity both are more, the momentum will be the greatest. So this means if a lighter and a heavier object is moving with same velocity, then heavier objects will have more momentum than the lighter one. If a small object is moving with a great velocity, it has tremendous momentum, and because of momentum, it can harm an object more severely. For example, a small bullet having a little mass even kills a person when it is fired from a gun. Usually, road accidents prove more fatal because of high speed than in slow speed. This happens because vehicles running with high speed have greater momentum compared to the vehicles with slower speed. Now, having learned about momentum, let us revise the term force which we had already seen. Force is an action that can change the motion of an object. A force is what we call it as a pull or a push or any action that has the ability to change an object's motion. Force can be used to increase the speed of an object, decrease the speed of an object, or change the direction in which an object is moving. So these are the basic concepts which we have already discussed with force. Now let us extend the force with balanced and unbalanced force in this slide. This is also a practical illustration which we can take it from the game called tug of war. So when you see the pictures on the right side, both the teams exert 300 Newton force on the opposite side. So as a result of which the rope doesn't move. It is kept stationary. It is not in motion. Therefore, this type of force where it balances on both the direction and which keeps the body at rest, it is called balanced force. So a balanced force is a force in which the net force equals 0 and there is no motion of the body. So the 300 newtons of force opposing the 300 newtons of the force on the right side. So a balanced force will result in no motion. There will not be any motion. On the other hand, look at the example down. There are two teams, Team A and Team B. Team A, they exert a force of 400 Newton towards the left. At the same time, the Team B exert a force of 300 Newtons onto the right. Then where do you think the motion will be? So who has won the game? Obviously, it is Team A since the force is 400 and when we compare with 300, it is greater force. Therefore, the Team A members will try to pull the Team B members towards them. That is toward the left of the picture. So there is a result. What is the net resultant of this force? So 400 newtons towards the left, 300 newtons towards the right. Therefore, the net resultant force is 100 newton towards the left. Therefore, this is an unbalanced force. So always an acceleration is created due to unbalanced force. Since the forces here are unbalanced, the Team A is pulling the opponent towards their direction. So this is a best example to describe that unbalanced force makes or creates acceleration. Now see to the slide. An unbalanced force is a force in which the net force is greater than 0, causing motion. 400 newtons of force opposing 300 newtons of force, therefore which is equal to 100 newtons is the unbalanced force with motion going in the direction of the greater force in the case of the left or towards the Team A. Children, let us apply the knowledge of the force that we have studied so far and the momentum that we have studied so far in knowing about Newton's second law of motion. Now consider this example. Look at the picture. A man is applying a force to the cart and the same man is applying the force more greater in the second case. Now let us compare the acceleration in both the cases. Let us imagine that in the first figure, the man is giving a force by using only one hand. So when he pushes, he exerts a force and because of that, the cart moves. So this is the force exerted by applying only one hand. Let us imagine the same man with the same cart with the same load. He is applying the force by using both of his hands. Right? Now, will there be any difference in the motion of the trolley? Yes, definitely. In the second case, the trolley moves faster than before. Why? When the force is more, the acceleration is also more. So this is the basic concept for Newton's second law. When force increases, the acceleration is also increases. Children, let us study this example in order to understand about the acceleration. Now, here also there are two pictures. The first picture, the man is giving a force to a cart filled with a load. So as a result of it, the cart moves. Now, compare it with the second picture which is down. What is the difference between the first and the second? In the second picture, the load is more. That means the mass of the body is more because more blocks are being filled with the cart. So let us imagine the same man applying with the same force. What will you think about the motion of the cart in the second case? Definitely the cart will move slower than the previous. So the acceleration is being slowed down. What made the acceleration to slow down? It is because of the increase in the mass. So what we have learned here in this case is acceleration is inversely proportional to the force. More the mass, less is the acceleration when the force remains same. So if the same force is applied to an object with greater mass, the object accelerates at a slower rate because mass adds its inertia. Children, let us understand the concept of mass and acceleration in this slide also. It is a very practical application where we use in our day-to-day life. Look at the picture onto the right. It is a bicycle and it is a two-seater bicycle. And in the first picture, only one man sits on the bicycle and exert a force. And because of the exertion of the force, the bicycle moves. That means there is an acceleration due to the force. Now, let us see to the picture which is down. One more passenger is being added with the bicycle. So what happened to the mass? The mass is now increased. And imagine the second passenger who was sitting behind applies no force. Then how will be the movement of the bicycle when compared with the previous one? Obviously, the acceleration would have been slowed down. This slowing down of acceleration is due to the increase in the mass. Therefore, when the mass is increased, the acceleration is slowed down. Now let us see to the slide. More mass results in less acceleration when the same force is applied. With the same force applied, the rider and the bike with the twice as much mass will have half the acceleration with all other factors constant. Note that the second rider is not pedaling. Now let us apply the two concepts together in a single slide and let us see to it. Now look at the second paragraph. As the force acting upon the object is increased, the acceleration of the object is increased. As the mass of the object is increased, the acceleration of the object is decreased. So acceleration is directly proportional to the force and inversely proportional to the mass of the body. The acceleration of an object depends directly upon the net force acting upon the object and inversely proportional to mass of the object. Yes, children, now let us go for the actual statement of the Newton's second law of motion. According to Newton's second law of motion, the rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. So this statement has two parts. So we have studied about momentum, and here we speak about rate of change of momentum. That means how much is the momentum changing per second. Rate means per second. So the rate of change of momentum of the body is directly proportional to the applied force. That means if force is increased, the rate of change of momentum is also increased. This is the first part. And the second part is and takes place in the direction in which the force is acting. So the direction of the movement will be in par with the direction of the force. That is the second part of the statement. So force is proportional to change in momentum divided by time taken, that which is called as rate of change of momentum. Let us discuss about the second part of this statement first. See to the slide down. For example, when acceleration is applied on a moving vehicle, the momentum of the vehicle increases, and the increase is in the direction of motion because the force is being applied in the direction of motion. We can take it a bicycle as a best example for this. So when we apply force to the bicycle, the momentum of the bicycle increases first, and the direction of the motion is in par with the direction of the force. Therefore, the bicycle moves forward. On the other hand, when brake is applied on the moving vehicle, the momentum of the vehicle decreases, and the decrease is in the opposite direction of motion because the force is being applied in the opposite direction of motion. So the same bicycle, when you apply the brakes, its speed decreases, and because of that the momentum is also decreased. Also, the direction in which the motion is there, it is also in the same direction as that of the force. So it is now acting in the opposite direction. Therefore, again, let us see to the statement of the second law of motion. Very important statement. The rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction in which the force acts. Children, we are going to derive an expression for the Newton's second law of motion. Now, let us take a body of mass m and let the object be moving with an initial velocity u, so that after some time t, it reaches some final velocity t. So see to the slide. Let the mass of the moving object be m. Let the velocity of the object changes from u to v in the interval of time t seconds. This means initial velocity of the body is u and the final velocity of the object is v. We know that momentum P is equal to mass into velocity. Therefore, momentum of the object as its initial velocity. That means we can even call it as initial momentum. So initial momentum is with the initial velocity. So m into u. Then final momentum. So final momentum is for the velocity, final velocity v. Therefore, the equation will be mv. So the initial momentum is mu and the final momentum is mv. So the change in the momentum, how much is the change in the momentum? That means final momentum minus initial momentum. So mv minus mu. So mv minus mu is the change in momentum. Rate of change of momentum. So already I told you that rate is per second, or we have to divide it by time. So mv minus mu divided by t. So this is the expression for rate of change of momentum, and this will be continued in the next slide. Now let us continue with the previous slide. So we ended with rate of change of momentum is equal to change in momentum divided by time. So rate of change of momentum is nothing but force according to the Newton's second law of equation. The rate of change of momentum is force. So we keep it by the letter F. So F is proportional to mv minus mu divided by t. This is the rate of change of momentum. Now since m is constant for both the numerators, m can be taken out. So m into v minus u by t. So v minus u by t, this is nothing but v is final velocity, u is initial velocity, t is time. So this is rate of change of velocity. Rate of change of velocity is nothing but acceleration. So a is equal to v minus u by t. Now let us substitute the remaining. F is proportional to m into a. So if we remove the proportionality sign, F is equal to k into ma. So when k has a value 1, then we land the famous equation F is equal to ma. So F is equal to ma is the Newton's second law equation, where F is the force, m is the mass, a is the acceleration. So from this we can derive the other equations. An equation for a is equal to F by m. So second one, F is equal to ma, as we had seen now, and m can be calculated by F by a. So these are the formulas related to F is equal to ma. Now we have seen the Newton's second law of equation as F is equal to ma, where F is the force. Now let us see to the SI unit of force. Since force is equal to mass into acceleration, the unit of mass is kilogram and the unit of acceleration is meter per second square. If force, mass and acceleration is taken as one unit, therefore 1 Newton is equal to 1 kilogram into 1 meter per second square. Thus Newton is equal to kilogram meter per second square. So equation can be also written as a is equal to F by m. So the SI unit of force is Newton. So the equation for acceleration is equal to A equal to F by m. This equation is the form of Newton's second law of motion. According to this equation, Newton's second law of motion can also be stated as follows. The acceleration produced by a moving body is directly proportional to the force applied over it and inversely proportional to the mass of the object. From the above relation, it is clear that acceleration increases with increase in force and vice versa. Acceleration decreases with increase in mass and vice versa. Now, look at this slide very carefully. This slide explains you about the acceleration of two objects. One is heavier than the other. Now, first figure, you can see a stone of bigger mass, and mass of that object is 10 kilograms. Whereas the stone on the right, it has only 1 kilogram. So the mass of the first stone is 10 times greater than the mass of the second. Now we know that weight W is equal to mg. So the weight of the first stone is 10 into 9.8, therefore it will be 98 newtons. So similarly, calculate the mass from the mass 1 kilogram, its weight. So W is equal to mg. Here the mass is 1 kilogram, therefore multiplied by 9.8. So it will be 9.8 newtons. So in the first case, mass of the object is 10 kilogram and the weight of the object stone is 98 newton. In the second case, the mass of the object is 1 kilogram and its weight is 9.8 newtons. Now let us calculate the acceleration for both the cases. So from the Newton's second law of equation, the second law of motion's equation, A is equal to F by m. So the force is nothing but its weight. The weight is 98 and the mass of the object is 9.8. Right? So A equal to 98 divided by 10 kilogram. The mass of the object is 10 kilogram. Therefore, the acceleration is 9.8 meter per second. Similarly, let us calculate the acceleration for the second case. Same formula, A is equal to F by m. Here the force is 9.8 Newton and its mass is 1 kilogram. Therefore, 9.8 meter per second. So, for the first case, the acceleration is 9.8 meter per second. For the second case also, though the mass is 10 times smaller, the acceleration is one and the same. So what can we conclude from this? Read the slide now. Newton's second law proves that different masses accelerate to the earth at same rate but with different forces. So this is the main concept of the Newton's second law of motion. In this slide, let us see to the applications of the second law of motion. The applications of the second law of motion can be seen in identifying the amount of force needed to make an object move or to make it stop. Following are a few examples that we have listed to help you understand this point. Kicking a ball. When we kick a ball, we exert force in a specific direction, which is the direction in which it will travel. In addition, the stronger the ball is kicked, the stronger force we put on it and further away it will travel. Pushing a cart. It is easier to push an empty cart in a supermarket than it is to push a loaded one. More mass requires more force to accelerate. Two people walking. Among two people walking, if one is heavier than the other, the one weighing heavier will walk slower because the acceleration of the person is comparatively less. Children, this is a very important concept on Newton's second law of motion. Often when you catching a cricket ball during the field, you are suggested to pull back your hands. So when a cricketer is catching a ball, you can see the cricketer draws his hand in the direction of the ball while catching. What is the reason behind this? First one, to reduce the impact of the ball on your palm. The action of pulling back your hand is like shock absorbing activity. Increase the time of the pulse. By pulling back your hands, the time of the pulse will be increased by reducing the velocity of the ball and reduces ill impact on your palm. Now let us compare a cricket ball being caught by a fielder without moving his hand, that is the first case, and by moving the hand in the second case, which is on to the right side. Now let us take the left hand side. Now the cricketer is catching the ball without moving his hands and catching the ball as it is. So there are two risks in this. One is there will be greater injury in his palm, and the second case, the probability of catching the ball will not be exact. The ball after reaching the palm may even drop down. Now let us take the mass of the ball. Cricket ball is somewhere around 150 grams. So in terms of kilogram, it will be 0.15 kilograms. Now when the velocity, the final velocity v minus u by t, right? F is equal to m into v minus u by t. We are going to apply in this. The mass of the ball is 0.15 kilogram. Final velocity, since the ball has reached the fielder, the final velocity is 0. And let us suppose before it reaches the hands of the catcher, the ball travels with 10 meter per second. So putting all the values in the formula m into v minus u by t, we get a result minus 15 newtons. So the minus sign indicates it is a retarding force. So let us neglect about this. So the force when the cricketer is catching the ball with less time, that is 0.03 seconds, as it without moving his hands. Therefore, it is 50 newtons. Now come to the calculation on the right part. So F is equal to ma, that is m into v minus u by t. So the mass of the ball is not changed. It is same 0.15 kilogram, and the final velocity obviously it is 0 because the ball comes to rest after coming to the hands of the fielder. And the initial velocity, there is no change. It is also 10 meter per second. See to the time. Previously it was 0.03 seconds. Now it is increased to 1 second. So how do we increase the time? The increase in the time here is nothing but pulling the ball. After catching the ball, you are pulling your hands in the direction of the ball. So it takes some time. So from 0.03 seconds, we extend it to 1 second by moving our hand in the direction of the ball. So when you calculate the force, here it comes around minus 1.5. So in the first case, it was 50 Newton force. In the second case, it is only 1.5 Newton force. Obviously very, very less, and it is 33 times lesser than the previous one. So it is advised to catch the ball after you pull it with the direction of the force. Now let us discuss some of the important questions on the Newton's second law. How does Newton's second law of motion apply to rockets? We know that according to Newton's second law of motion, the force is the product of mass and acceleration. When a force is applied on the rocket, the force is termed as thrust. Greater the thrust, greater will be the acceleration. Acceleration is also dependent on the mass of the rocket. Lighter the rocket, faster is the acceleration. Second one, how does the Newton's second law apply to a car crash? According to the definition of Newton's second law of motion, force is the dot product of mass and acceleration. The force in a car crash is dependent either on the or the acceleration of the car. As the acceleration or mass of the car increases, the force with which the car crashes takes place, which is also increases. What are Newton's second law examples in everyday life? Following are Newton's second law examples in everyday life. Pushing a car is easier than pushing a truck with the same amount of force, as the mass of the car is lesser than the mass of the truck. In golf game, the acceleration of the golf ball is directly proportional to the force with which it is hit by the golf stick. Also, the force applied is inversely proportional to the mass of the ball. Next question. What is the other name for Newton's second law? The other name for Newton's second law is the law of forces and acceleration. What are some daily life examples of Newton's second law of motion? Newton's second law of motion explains how force can change the acceleration of the object and how the acceleration and mass of the same object are released. Therefore, in daily life, it is there very change in the acceleration of the object due to the applied force. Then they are the examples of Newton's second law. So acceleration of the rocket is due to the force applied, known as the thrust, is an example of Newton's second law of motion. By this, we come to the end of today's learning, children. So we have seen about the force, we have seen about balanced and unbalanced force, we have seen about momentum and we have seen about acceleration. So all these three factors, force, momentum and acceleration, are applied in the concept of Newton's second law. So we have finally derived an equation F is equal to ma, which is the basic of the physics Newton's second law of motion's equation. Force is equal to mass times acceleration. And we have seen some examples of this second law of equation, and also we have seen the examples for momentum. So this is a very important topic, Newton's second law of motion. So learn it until you understand. And after you go through the video, just go through your textbooks in order to apply the knowledge you have gained hand in hand with your textbooks. So have a very good informative day, and we will meet somewhere next week, children. Until then, bye from you.